Hello and welcome to transforming the reciprocal function. First, what is the reciprocal function? Well, the basic form of our reciprocal function is f of x equals 1 over x. That is, the reciprocal of f of x equals x. So there you have it, our reciprocal function, in the most basic case of our rational functions. If I want to transform this in our AHK transformation, then I am going to have a f of x minus h plus k is going to give us a over x minus h plus k. And let's remember what all of these things mean, right? Grab another color. A here is going to be our stretch or compression, but also the sign of A is going to give us our reflection over the x-axis. In this class, we have not worked with reflections over the y-axis, so I'm just going to leave that there. K here is going to give us our vertical shift. And that is going to shift our horizontal asymptote up and down. H is going to give us our horizontal shift. And the horizontal shift is going to shift our vertical asymptote to the left or right. So let's also grab yet another color and consider our asymptotes. Our asymptotes for this function are going to be at y equals k and at x equals h. So let's grab a clean page and look at a quick sketch of what this looks like. So if we consider our function y equals 1 over x, and I consider a y-axis and an x-axis here, then grabbing another color, we're going to have a horizontal asymptote here, right on the x-axis, and a vertical asymptote here, right on the y-axis, that can be shifted by looking at our h and k. And the basics of our function is going to be a curve like this, forever approaching the asymptotes, and a curve like this, also forever approaching our asymptotes. And if we look at this function, we are going to have a discontinuity here, and we have a discontinuity. This means that I would have to pick up my pencil in order to draw this function continuously from left to right. So we have a discontinuity in the function because I can't just keep drawing it without ever picking up my pencil. So let's look at our first question. So we have our parent function. This is the parent function of the reciprocal function family right here. And it's asking me to move my horizontal asymptote to 4 and my vertical asymptote to 3. So I'm going to write y equals, that's not giving me a stretch, compression, or reflection, so it's going to be 1 over, and then I need x minus h, and I need my plus k on the end here, which is minus 3, and there I have the function with asymptotes at x equals 4 and y equals minus 3. I have just shifted. Here's my x and y axis, and I'm going to have a horizontal asymptote at y equals -3. And I'm going to have a vertical axis at x equals 4. Y equals, and this would be x equals 4. And when I go to sketch my graph, which again we should grab another color for, we're going to have something like this. Did not succeed in grabbing another color, but you can get the idea of what this is going to look like. So there's my transformed function. All right, let's look at the next question. Here we have a transformed function, and we need to identify the parent function. So the parent function is going to be y equals 1 over x, and we need to describe the transformations. Well, we have reflection over the x-axis. We have a stretch by a factor of 4. And we're going to have a vertical shift up 2. And those are all our transformations. One more question for this video, and we'll put the definitions into another video. We're being asked now to state the asymptotes, to identify the domain and the range of the graph of y equals 1 over x minus 2 minus 7. Well, the asymptotes are going to be at h and k, so we'll have asymptotes at x equals 2. Remember, it's minus h, so h is going to be the negative of whatever we have here. And we're going to have an asymptote at y equals -7. The domain are all the allowed values of x. Well, we can't have division by 0, so the domain is all real numbers with the exception that x is not equal to 2. And for our range, these are all the values of y that we're going to get, and that's also going to be all real numbers with the exception of the asymptote, so y not equal to -7. And there you go. We shall take a look at the definitions in the next video.